So for our third video, we'll finish up graphing log functions. We'll do more of that in class, but just the basics, you have an input that's different than the input of log base 10. Okay, so this is a log base 10 of x, so y equals log base 10 looks like this. Okay, and so we know that when the input changes from x to x minus 2, that the graph of the original function gets shifted. Okay, and you should know what this shift is. Okay, so the original graph, let's do that in green. So this is the original graph, okay, of y equals log base 10 of x. Okay, so it's the log base 10 of x. This graph, the key point is what is really important to keep track of, and the key point then, as well as everything else on this graph, will shift to the right 2 units. So if we take the key point and we move it to the right 2 units, it moves right there. And then don't forget, we had a vertical asymptote on the graph of y equals log base 10 of x, and the vertical asymptote then, if we're moving left and right, has to move with us. So the vertical asymptote then also moves to the right 2 units. And so now we have a vertical asymptote of x equals 2. Okay, and then since the graph of this function used to be here where the green dotted line is, everything moves to the right 2 units. Okay, and so that right there is the log base 10 of x minus 2. That's y equals log base 10 of x minus 2. I've got some great visuals to show you in class as well. To drive this point home, the domain is all real numbers x greater than 2. So for x values greater than 2, or you can, if you like to write it in interval notation, 2 to infinity. The range again is all real numbers. An x-intercept that used to be there at 1, 0 is now at 3, 0. Okay, and the y-intercept, that there is no y-intercept, doesn't even get close to the y-axis. The asymptote we can see clearly, and like I said, was x equals 2, and the key point that used to be at 1, 0 is now at 3, 0. Okay, well, let's find the inverse of this function, y equals log base 10 of x minus 2. So to find the inverse, we first start with log base 10 of x minus 2. Okay, switch the x and the y. Log base 10 of y minus 2. Solving for y, we have to get rid of our log here, because we can't solve for y there with a log there. So we have x, or 10 to the x, is equal to y minus 2, and so y, being the inverse of f, would be 10 to the x. If we add 2 to both sides, we get 10 to the x plus 2. Okay, and so now we just reverse that process. Now we could do this a couple different ways. We can just look at the graph of log base 10 of x minus 2 and draw the reflection, or we can just draw y equals 10 to the x, which would look like that. There's 10 to the x, and if we remember, the key point would be 0, 1, and then we move that up 2 units to there. And keep in mind also that we're moving everything up 2 units, which would include the horizontal asymptote. So this horizontal asymptote now becomes y equals 2. Of course, we could have gotten that from the information above for the other function. And now we, again, just move everything up 2 units. And there you go. Y equals 10 to the x plus 2, which would have a domain of all real numbers. So we reverse the domain and range for these functions. The range is all y values such that y is greater than 2. Okay? Or you can just write 2 to infinity, not including 2, and not including infinity. I mean, it just goes all the way, it just keeps getting higher. The x-intercept is none. The y-intercept is 3. The asymptote, instead of being x equals 2, is y equals 2. And the key point, instead of 3, 0 on the function, we have 0, 3 on the inverse of f of x. Okay? Alright, so there's graphing. And then we have finally solving these equations. So I know there's a lot here We'll do a lot of practice in class, but this is good stuff because you're getting kind of like the big picture all at once instead of getting bits and pieces of log functions. You get them all at once, and then process. You'll be able to process that, see the big picture, see that they're just functions, and then during the next lesson we'll actually learn the properties of logs, and we'll go from there. But for now, one of the things that you learn all of these properties of logs for is to be able to solve logarithmic equations. Now the more complicated log equations come later, but currently we have the basic log equations that can be solved without too much trouble. Okay, so we have log base 5 of x equals 3. What I want you to keep identifying every single time, and I'll try to continue to repeat this, is where is the variable? Okay, so that's a key question. Key question. Where is spelled with an E at the end, is the variable. Okay, so where is the variable? Well, here the variable is in the argument. Well, if it's in the argument, we have to convert to exponential form. So we have 5 cubed is equal to x. Well, there, we're done. See that? See how easy that is? You just convert it to exponential form. Okay, here the variable is in the base. Well, if it's in the base, you have to convert it again. X cubed equals 1/8. X cubed equals 1 over 2 cubed. So that's 1 over 2 cubed, which is equal to 2 to the negative 3. And if the x cubed equals 2 to the negative 3. Yeah, well, let's do it like this. Let's write it as 1 over 2. Let's do that. 1/2 cubed. Let's write it like that. So if x cubed is equal to 1/2 cubed, then the x must equal 1/2. I mean, you could take the cube root of both sides if you want, and the cube root cancels out to the third power, and so therefore x is equal to 1/2. Okay? And then over here, number 3, at any time feel free to, I see some nasty ones coming up. Feel free to go ahead and pause the video and fast forward if you want to not have to sit through my work if you feel like you've got it. Here we see the argument is the place where the variable is at, and so since the argument is where the variable is at, we have, and now at this point I write ln at e, so this is really log base e. So if the variable is in the argument, we have to convert to exponential form. So if it's in a place you can't get to it, convert to the other form. So we have e to the 8th equals e to the negative 2x. Therefore, since the bases are the same, we equate the exponents. 8 equals negative 2x. Divide both sides by negative 2. And we get x is equal to negative 4. Please don't tell me that you can't take the log of a negative number, because I already know that, and you know that. And just because you get a negative number for x doesn't mean you're taking the log of a negative number. Okay, so put it back in there, and you get ln of, you'll see you're not taking the log of a negative number just because x is negative. Okay, alright, over here we see where the variable is. The variable is not locked up in the log. It's not in the argument, it's not in the base. Therefore, we don't have to convert to exponential form. We know that the log base 6 of 36 has a value of 2. Okay? So when students get locked into a rhythm, they go, oh, I've got to convert to exponential form every time. Well, guess what? You don't have to do that. Okay? Here, again, the variable is not in the argument, not in the base, so we don't have to convert to exponential. But what we do have to do is subtract 3 from both sides, convert the log base 6 of 36 to 2. 2 minus 3 is negative 1. Negative 1 equals 5x. And therefore, when we divide both sides by 5, we get x equals negative 1/5. Okay? We are not going to do number 5 yet. We're not going to do number 6 yet. We could do number 7. Let's do that. Okay, number 7, we've got our variable here in the argument. We're going to convert to exponential form. 5 squared equals x squared plus x plus 4. So if we subtract 25 from both sides, we're going to get x squared plus x minus 21. Really? Doesn't seem like it's going to be a good one for us. Equals 0. And we're going to need the quadratic formula right there, so I'll just leave that alone. Okay. We already did. I could tell the quality of these problems is deteriorating quickly. We already did number 8. Number 9, we have 3 to the negative 1. Notice that the variable is in the exponent here of the argument. So it's locked up, so we're going to have to unlock it. Write it as, remember, flower power. Okay, 3 to the negative 1 is equal to 3 to the x. Oh, therefore, since the bases are the same, the exponents have to be equal. Okay. Over here, we're not going to do number 10. Yeah, good, we're almost done. And we're not going to do number 11 either, we'll do those later. Okay. And finally, number 12, we already did that, so we're done. How about that? We're all done. So good job. That's not an easy lesson. I know it's tedious, but we'll do some practice in class. I may have some extra practice problems for you to submit your answers to online, but it's not going to be many. And then give me some feedback on the Google form as well. So I'll see you in class.